Hello everyone, welcome to the video lecture series of eigenvalues and eigenvectors. I am Mayur Gohil. In this video lecture, I will be discussing method 3 to find eigenvalues. Now, before we start discussing the method, this method is slightly advanced than the previous two methods, that is method 1 and method 2. It involves technical mathematical concepts. So if you find method 1 and 2 comfortable, stick to those two methods. We generally use the method 3 when the order of the matrix is more than 3 cross 3, that is either it is 4 cross 4 or 5 cross 5 or even larger than this, or when the entries in the matrix are very large numbers. So that time this method becomes very helpful. It is generally used in advanced calculations. So let us try to understand this method. I am trying to describe the entire method using this procedure. I have divided the procedure in 3 steps. The first step is that we already know that we are dealing with a square matrix A, which is an n cross n matrix. Lambda is our eigenvalue, which is a scalar, and x is a non-zero vector. The concept always begins with Ax equal to lambda x, where x is non-zero, indicating determinant of A minus lambda I is equals to 0. Okay. Now this determinant of A minus lambda I equal to 0 is nothing but our characteristic equation. So in order to solve this determinant, we use the following row or column transformation, that is Ri changing to K1 Ri plus minus K2 Rj, or Ci changing to K1 Ci plus minus K2 Cj. Using this row or column transformation, we try to establish maximum number of zeros in determinant A minus lambda I if possible. Okay. In this step, we generally try to establish maximum number of zeros in a particular row or in a particular column, or even at other places also, but we generally choose a particular row or a particular column. Then what we do is we apply the general expansion of determinant formula, that is Laplace expansion formula, along the row or the column having maximum number of zeros and solve the polynomial in lambda. What is this expansion formula? Laplace expansion formula, or the general formula to find a determinant over here we are using is determinant of A is nothing but summation Aij into Cij, where j runs from 1 to n for a fixed I, where what is Aij? Aij is the ijth entry of the matrix A, and Cij is nothing but minus of 1 to the power I plus j times Mij, and Mij again is nothing but the determinant of the matrix obtained by deleting ith row and the jth column. If you remember, Cij is nothing but the cofactor. Okay. And similarly, if you can also go along a column, that is you fix for some column, fix j, and you can run over the rows also. The same formula works. Now let us see this entire procedure with the help of an example, because there is lot of technical mathematical terms involved over here, and the formula also we will have to understand. So let us see how to go with this method with the help of an example. Consider this question. Here I am taking a 3 cross 3 matrix in order to explain you people, so you can get the hold of the concept. So we have to find the eigenvalues of A. Okay. Now the procedure in the beginning is same. You write determinant A minus lambda I equal to 0. That means what we have to do is nothing but you write the matrix in a determinant notation that is these are the two vertical bars, and then you have to subtract lambda from the diagonal elements. Once you subtract the lambda from the diagonal elements, you obtain this format. Okay, now we have to solve this determinant. How can we solve this determinant? It is, now we are going to use the row and column transformations that I had mentioned just now. Now, using that, let us try to understand how to use them. Observe here the first row. If I add the column 1, column 2 and column 3 all together, and I'm going to make change in column number 1. So what will happen? 2 minus lambda minus 2 plus 3. That is nothing but 3 minus lambda. Same way, observe here, it is 1 plus 1 minus lambda plus 1. If you add all of the 3 elements over here, it is nothing but 3 minus lambda again. Again on the last row, if you add all the 3 elements, it is nothing but 1 plus 3 minus 1 minus lambda, that is nothing but 3 minus lambda. So I am now going to apply the following transformation, that is C1, that is column 1 is changing how? Column 1 plus column 2 plus column 3. So I obtain following change in my original determinant. Now remember, the value of the determinant does not change by doing this transformation. Okay, so what we observe here, the first column has now become 3 minus lambda, 3 minus lambda and 3 minus lambda. Okay, so all the entries are now 3 minus lambda. Now the next, if you can guess, this is nothing but the property of determinant. That is, if any row or any column has a common factor, we can take it outside the determinant sign and multiply it. So that is what I have done. I have taken it outside and multiplied it. That's it. So 3 minus lambda is multiplied to the determinant, and whatever is left, you keep that. It is like 3 minus lambda is the GCD of the column, right? So you just take it outside. Now what is remained over here is 1, 1, 1, and the other two columns remain unchanged the way they are. Okay, now I am performing the following two row operations, that is R2 is changing to R2 minus R1 and R3 is changing to R3 minus R1. Okay, so what I am going to get is this 3 minus lambda factor remains as it is. Since R2 is changing, the following changes are done, that is this element A21 becomes 0, then 1 minus lambda will become 1 minus of 2 over here, so that will become 3 minus lambda, and similarly 1 minus 3 will become minus 2. Okay, and then over here 0, 3 minus of minus 2 becomes 5, and minus of 1 minus lambda will become minus of 1 minus lambda minus 3 will become minus 4 minus lambda. Okay, so you perform these two row transformations, you will get this as your answer. Okay, now observe here, as I had said, our goal is to establish maximum number of zeros in the determinant along a particular row or a particular column or in the entire determinant. Now what I have done here is I have been able to establish maximum number of zeros along the first column. So there are 2 zeros available. Okay, now I am in a position to calculate the determinant over here in this matrix. Okay, so I am going to use the general expansion formula. Recall the general expansion formula that I had stated. Okay, there were two versions. Either you can fix the row or you can fix the column. Since it is column I am having over here, I am fixing the column. So determinant A is nothing but summation I running from 1 to n Aij into Cij for a fix j. Okay, and Cij is nothing but the cofactor. So let us see how to calculate this. What will happen is 3 minus lambda will remain outside. We are now focusing on the determinant calculation. So 3 minus lambda will remain as it is. And now Aij meaning A11 over here. So this first element will be written as it is. So this is the first element 1 over here. Okay, then it is telling for me, it is asking me to calculate Cij. Cij is nothing but minus of 1. So that is the minus of 1 to the power I plus j. Now what is I plus j? It is for this position, right? It is A11 position. So that means it will be nothing but 1 plus 1. Okay, that will become 2. And then it is Mij. Mij is nothing but the determinant of the matrix obtained by deleting the ith row and the jth column. So you delete the first row and first column, and whatever is the matrix obtained, submatrix, you take its determinant. So that is 3 minus lambda, 5 minus 2, 4 minus lambda. Now you can easily calculate this. On calculation, what we will obtain is 3 minus lambda, and further when you simplify this determinant, you will obtain this. But remember, there is this bracket. Okay, and then further you calculate by expanding this, and you will obtain 3 minus lambda into lambda square plus lambda minus 2. And further, when you simplify this quadratic, you will obtain 3 minus lambda into lambda plus 2 into lambda minus 1 equal to 0. Okay, now this is our characteristic equation in factor form. So now what we can get immediately is lambda is equals to 1, 3 and minus 2. So these are our eigenvalues for the given matrix A. So we have found our eigenvalues. Also we have found our characteristic equation in factor form. Okay, these are the factors available. If we multiply this directly, okay, we will get our characteristic equation in polynomial form also. So this is the advantage of method 3 over method 1 and method 2, that you directly sometimes obtain the factor form of the characteristic equation. So I'll just put a red star over here so that you remember that these are the two important forms that we always keep on highlighting. So we are finally done by method 3, that how to find the eigenvalues of a given matrix. It is basically using the properties of determinants and then one advanced formula of determinant that you might have seen for the first time. And once you are done through it, and it's easy. Okay, so this is the method. For your practice, you can take these two examples, try them by yourself. If you have any difficulties regarding solving these two problems or any other problems related to the topic that we have discussed, I would be glad to help you. So till then, thank you.